Hey guys, welcome to Maths with a Subnormal. In our today's class, we provide a solution to this initial Olympiad maths problem we have on the board. We are told to solve 3 power x plus 2 minus 2 power x plus 1 is 0. Our goal here is to find the value of x that will satisfy this particular problem we have on the board. Okay, so since we have this particular equation, we must know some of the rules of exponents and logarithm because it plays a very important role in finding the value of the solution. But first thing we have to do is that we have to note that in this place, since we have to make the terms to be in both sides of the equation, so we basically have to add plus 2 to both sides, or we say that 2 power x plus 1 have to cross the equality sign. So we write it as 3 to the power of x plus 2 is equal to 2 to the power of x plus 1. So at this stage now, they are on the both sides. You understand one thing, the base here is 3. This is called the base, is 3. And these are the powers. X plus 2 is called the powers, or we call it the exponents. Same thing is applied to here. This is the base, and this is the what? Powers. Okay? These are the powers. So at this stage, you understand that this particular base are different. They are not of the same base. This is base 3, and this is base 2. And since they are not of the same base, we cannot actually equate their powers. So what we have to do is to employ the laws of logarithm. Remember in the laws of logarithm that in a situation where we have something like log of base a of b to the power of m, for instance, it is the same thing as m multiplying the same logarithm. Nothing have changed. We accept that in logarithm. So in that case, we are now going to take the logarithm of both sides so that we can now multiply the powers to it. So if we take log of base 3 of x plus 2 is now equal to log of 2 of x plus 1. Now we have to apply this particular, theory or law. So applying it, you can now see we have it as log, we have it as x plus 2, this power now is now multiplying the logarithm of 3 is equal to, this one is x plus 1, we have it as what? We have it as x plus 1 multiplying log 2. Okay? So the next thing we have to do is just simply to open up this bracket. Remember, this is log 2 and this is log 3. And for them to open the bracket, we have to use the same logarithm to multiply the two terms in the bracket. The first term here is x and the second term here is what? 3. Okay? So you can now see that log 3 times x will give you x log 3. And log 3 times 2 will give you plus 2 log 3, and it is equal to log 2 with the same thing to this will give you x log 2, and log 2 will times 1 to give you plus log 2. Okay, look at this place now. If you look vividly well, you see that 2 is here. And this particular 2 is multiplying the logarithm. We can also take it as power. That's applying this particular rule again. So instead of having 2 to multiply this particular log now, we can now take that 2 to serve as the power. So we write it to be x log 3 plus log 3 to the power of 2. That's applying this particular rule we've already stated initially, and it is equal to x log 2 plus log 2. So here you can now see, since we have it that 3 squared is 9. Okay, So we have it that we have to collect like terms, bringing the terms that have x together and taking the terms that doesn't have them in the other side of the equation. So here, to do that, we now do x log 3, then we are bringing x log 2 to the other side, so it's crossing the equality sign, so it gets a minus x log 2 is equal to, what is left in this side of the equation is log 2, so we have to write log 2, and this particular log 3 will now cross the equality sign, also getting minus log, remember 3 squared is 9, log 9. Okay, so since we have this, observe one thing, x is common in these two, so I can factor out x. So if I factor out x, I'm having x, I'm left with, what's left here, we'll be left with log 3. I have it as log 3. If I factorize out x here, I'm left with what? Log 2 minus log 2. And this is equal to, if you look at this, I'm still having nothing to factor, log 2 minus log 9. Okay, next thing we should have in our mind is that another theory of logarithm. In that theory, it says that whenever we are subtracting, let's say we have log a minus log b, that this particular log is the same thing as log of a over b. That whenever we are subtracting logarithm in common base, we will simply divide their numbers. Observe one thing here. We are subtracting this log in the same base. They are of the same base 10, base 10. So we have to divide the numbers 3 and what? 2. So we have it that x into, we have it as log 3 over 2 now is now equal to, if you look at this, we are also doing division. This is subtraction, right? So we have it to be log 2 over 9. Okay? So the next thing we have to do to find that value of x, which is our main goal in solving this particular initial quotient, is to divide the left and the right hand side by log 3 over 2, log 3 over 2. Log 3 over 2 will cancel out. You can now see that our x is now equal to, if you put this particular number, you have to key this number in a calculator to know the decimal solution. Okay, so if you key this number in a calculator, you'll be getting number. Can you make a guess? Let's know if you know that. So you're getting numbers that are approximately minus 3.71. So x is basically minus 3.71. So that's what we got, and that's the value for x. But most times it's very, very important that we check whether our answers are right. So to check whether our answers are right, all we have to do is to look at our initial problem we solved, which is 3 to the power of x plus 2 is equal to 2 to the power of x plus 1. So, and we got the x value to be that x is equals to approximately minus 3.71. So we look at the terms in the left hand side, that is all these terms here. The term says that 3 power x plus 2. We are now putting in the value of this x, which is minus 3 point this. And this is going to give us number like 3 to the power of minus 3.71 plus 2. And this is the same thing as, when you put it, you are getting it to be 3 to the power of minus 1.771. Okay, so since you are getting this, and when we have a negative value in exponent like a to the power of minus m, for instance, in indices is the same thing as 1 over a to the power of m. Okay, so we are going to apply it in this particular form. If you apply it, all you have is 1 over 3 to the power of 3 to the power of, so we have it that 1 over 1.71, okay, we have it that 1 over 3 to the power of 1.71 is the same thing as, when you key this into the calculator, you are going to get 0.1527 and so on. Then we have it to the left hand side. Then to the right hand side, where we have 2, right? We have 2 to the power of x plus 2 plus 1. So you know that we have it as 2 to the power of, our x is minus 3.71, then plus 1. What is it giving us? You see that this is giving us 2 to the power of minus 2.71. Applying this particular law of indices again, we have it that 1 over 2 to the power of 2.71. And this is exactly 0.1528 and so on. So you can see that our answer is what? Right. Okay? And that's the answer. If you like this video, please like, share, also subscribe so that you get notified whenever I make a new post. Thank you.